Hi there, my name is Dan Friedman. I'm a data center TSA at Cisco. Um, and I wanted to create this video about pyATS and Genie. So pyATS is basically a test framework, and Genie provides some library functionality to that framework. And the reason I wanted to make a video about this is because I've made a couple of attempts to watch other videos or read documentation and understand this topic a couple times in the past, and to be totally transparent, right? I never really had something to execute this against, so I struggled. And this time, I tried again, and I'm finding the topic to be relatively straightforward. Maybe that's because I got my DevNet Pro back in March, and just a lot of the language and concepts sort of surrounding all of this make more sense to me now. But anyway, I wanted to try and take a quick stab at giving you some resources and talking through who, what, where, when, why, and how of pyATS and Genie. So the first thing I did was I went to ciscolive.com, clicked on the on-demand link up at the top, did a search for pyATS, looked for something in 2023, and found a presentation called Test Driven Automation by John Capobianco. And I thought this was a pretty good presentation. He talks about test driven development, he talks about unit testing, and these are topics that are covered in the DevNet Associate and/or DevNet professional certifications, so I'm not going to cover them here. But to suffice it to say, you should know something about test-driven development and unit testing, as it will make the test cases capability of pyATS make more sense to you. The next resource here is a document. I think I went to Cisco www.cisco.com/pyats, took me to kind of a home page, and then I followed that to some documentation. And that's this first link here, Cisco pyATS Network Test and Automation Solution. Now, this is an interesting web page because it has reference to a lot of external documents. So you'll see these little callouts that will open up a new tab. So if you just click at the very, very top, like introduction or whatever it starts with, and then you read that page and you go down to the very, very bottom and you click the next button, it will take you through certain parts of this web page. But what it won't do is take you through all of those external documents. So if I were you, and what I did is I started at the beginning and I clicked through from start to finish, but skipping all of the external documents. You can dive into those later as you need to. Right now, you're just trying to get the basics under your belt of what is pyATS and Genie, and what's all the terminology, and what's the purpose. The next document is pyATS developer documentation. This explains how to install and use pyATS. And when you install the framework, you will get both a command line utility as well as libraries that you can use in your Python script. So what that means is you do not have to actually know Python in order to use pyATS. You'll need to follow some basic setup instructions, so familiarity with Python will make that very easy for you. Otherwise, you can just follow the instructions. But once installed, you don't actually have to use Python to programmatically interact with your network. You can just use the CLI utility to achieve all of the functionality basically that pyATS has to offer, and Genie has to offer. And then finally, there's a link to hands-on learning. Obviously, this is a great way to learn any technology, is get your hands dirty. So there's a whole bunch of different options presented on that page. So let's talk real quick about who uses pyATS. Primarily network engineers and developers, right? This is pyATS is a mature test framework, and it runs millions of tests per month. So this was initially internal Cisco opened up to the masses, right? Opened up to the public. And because it was developed by Cisco for Cisco, it has a lot of support for Cisco products, but it is not uh, a Cisco specific or a Cisco only test framework. You can actually use pyATS to test against uh, many different manufacturer equipment. And if you have the skills, you can write parsers for any kind of network equipment, even if it's not Cisco or one of the currently supported third-party manufacturers. So it's very flexible, and you can write code to make your own parsers, etc. Okay, so what exactly is pyATS? And to boil it down into one sentence to keep it really, really simple, pyATS is a mechanism or a means to help you understand and manage the configuration and operational state of your network devices while providing you with structured data output. So if you don't know what structured data is, then examples are JSON or YAML or Python dictionary. All of these are structured data formats, and using Python and various utilities, you can actually convert JSON to a Python dictionary, and then you can convert that to YAML. So that's in a way of saying you can convert all of these formats to whatever format is most suitable to your purposes and your preferences. So most people at this point have probably seen a YAML file. This is commonly used in tools like Ansible and Docker. So that is one example of structured data. A structured data just means that the output information that you're given by running some process or in a highly structured format that you can parse. And that makes for very easy testing, and I'll try and talk through some examples of that moving forward. So that's what pyATS is in a nutshell. Now, how does pyATS work? The first thing is it requires or it relies on a test bed. And a test bed is just a file that tells pyATS how to connect to your network topology devices, right? So in the documentation, you might see reference to something called Unicon, and this is basically the Python library or class that handles how pyATS actually connects to your network devices. So just understand that in context. You don't need to go dig into the code or anything like that. Now, in your file, and your testbed file is typically defined in YAML, this is where you'll define your devices, right? And devices is literally the only key required in a testbed file, but there are other keys, such as testbed itself, where you can abstract credentials from individual devices and apply them to all devices in your testbed by including the credentials under the testbed key. And there's also a topology key, and that is where you would define how one device connects to another device. But for now, we're just going to focus on the devices key, which outlines the host name, management protocols, IP addresses, credentials, and other basic information that would be needed for pyATS to understand how to connect to your network devices. Okay. Now, there's multiple ways to create a testbed file. You can write it from scratch as long as you understand what the formatting is and the rules behind YAML in terms of spacing, indenting, and colon usage, etc. Or you can use the pyATS CLI to generate a testbed.yaml file for you from a spreadsheet. So you can download a template spreadsheet, populate it with your device information, run the pyATS CLI against that spreadsheet, and output a testbed YAML file, which you can then use moving forward with pyATS for your topology. And there's other methods too. So let's see here. Some of the fields in the spreadsheet, for example, or in the YAML file that you would need to populate include the device operating system. So for example, iOS, NXOS, etc. The platform, which really describes physical or virtual hardware name, and Um, and then device type, right? And that might be something like a router. So if you're interested in seeing examples of different platforms, you can click on the supported platforms link in the third bullet point here. But basically, pyATS will use the information in the testbed file, specifically the device OS, the platform, and the type, to try to figure out which connection plugins within the Unicon class or library and services it needs in order to connect to your device. So it basically is doing a whole ton of work for you to figure out how to make those connections, but you have to specify these bits in your testbed file. Okay, so now that pyATS kind of understands, what does your network topology consist of? How are your devices connected to each other? What are your devices? What are the management IPs and protocols and ports and credentials? And it can establish connection to each of those devices. What can you do with pyATS? The first thing is, if you imagine just connecting to a single device, you can use what I call the parse functionality. And parsing um, is basically used for generating unique structured output from individual show commands. So typically when you use the pyATS CLI, you would say pyATS parse, and you would specify a single command. And obviously, you're running that command against a certain type of device, and you get very specific, unique structured output from that command. Um, if you were to run a similar or same command against a different manufacturer device, then you may get a different structured output, right? The type of output, for example, JSON, would be the same, but the key value pairs available within that output may be different, and the hierarchy of the output may be different. So just keep that in mind. Parsing is typically to run single commands with unique output across different devices. And then another functionality is learning. And learning is a little different than parsing. It's more comprehensive, and I think it's a really cool feature. So this is used to generate uniform structured output, or what we'll call models, from various feature or protocols running on the device. And so the way that this is done is that you will say something like learn OSPF, and as a result of typing that in, the pyATS framework will run multiple show commands needed to fully understand the OSPF protocol, and then it will take its understanding of that and break that down into a single structured output. And this applies across different manufacturer devices, which means you can learn OSPF against a Cisco device or a Juniper device. It doesn't make any difference. The output is going to be the same, which is pretty cool. Okay, so the difference between parse and learn: parse is one command, learn is many commands. Although to you it's just one command because you're just saying learn, but in the background it's running multiple commands. And the other difference, right, is parse has potentially different outputs for different manufacturers, whereas learn has the same output for different manufacturers. Okay, now another capability is configuration, right? And this is used to push configuration to devices. And you can do this in multiple ways. You can use raw strings like, config t, interface gig 1.1, description, and provide a description, switch port mode access, switch port access VLAN 10, right? You can send each of those raw strings in unison, and the pyATS conf capability will execute those commands against the device. Another way to do this is using what's called Genie configuration objects. So for the conf capability, there's no pyATS CLI option, right? And the reason for this is because typically, when you're using pyATS, you're using pyATS as a test framework. So based on success, or typically more probably failure of a certain test, you might want to take a certain action, including maybe configuring a device. So if you find that an interface is down, like shut down, then you might want to attempt to do a no shut on that specific interface as an action. So for that reason, um, we're not, the pyATS library does not provide configuration capability from the pyATS CLI. It only provides this capability within Python scripts. So that's just something to keep in mind. Let's see here. Genie configuration objects use consistent data structure like I described for the learn functionality up above, models. And so what that means is that you've got a single data structure that can be used to configure multiple device types. So imagine you've got a data structure that describes the configuration of BGP, right? The AS number, the remote AS number, the neighbor IP address, and the protocol family, and so on and so on. So within that structure, you can go in and you can populate those values, right? So you would say maybe the local AS number is whatever value 65,000, and the remote AS is 65,001, and the neighbor IP address is 2.2.2.2, and so on and so forth, right? You would populate all those values into this file, and that one file, that one structure with the populated attributes can then be used to configure multiple potential devices, right? And because pyATS understands your test bed, right? How to connect to each individual device, and the operating system, platform, and device type, then it understands what's needed to basically apply that data structure, that configuration to that particular device. Now, that doesn't mean that you want to apply the exact same configuration to every device. It just means, you can use Python to push that configuration maybe to a specific device name within your test bed. Okay. So the next thing that you can do with pyATS is you can do compares, right? And this has to do with taking snapshots of your operational or configuration state data, right? So if you imagine a configuration that has router BGP 65000, and that's a critical part of your configuration, right? Because that protocol is establishing neighbor relationships with other adjacent routers so that you can send and receive routing information. And if that configuration line were to disappear, it could be catastrophic, right? It could cause a lot of problems. So that's one way of analyzing your environment, is you want to do a check and make sure that router BGP 65,000 is always in your configuration. That would be one way to do it, right? So you would check to see if it was in the configuration in snapshot 1, and then maybe that was yesterday, and then in snapshot 2, which was today, you'd check it again, and you'd make sure that there was no difference, no diff, right? Diff functionality, like in Linux or programming. So that's one way to do it, right? Another way to do it would be to use the operational state data from BGP rather than just looking at the configuration line. Operational state data could actually be even more meaningful. So you might want to check for certain neighbors, right? Neighbor relationship is in the up state. So, you can learn BGP on yesterday and capture the operational state of BGP yesterday, and then you can relearn it again today, and compare today versus yesterday to see if yesterday there was a neighbor relationship, but today that neighbor relationship is down. So that can indicate to you that your network is having a problem. So these comparisons can be run on demand, or they can be scheduled. And if they're scheduled, what you're essentially accomplishing is regular, periodic network monitoring of current state versus some previous state, right? And then based on the difference between those, if differences are identified, then you can determine some action that you want to take. Maybe that's attempting to push some configuration to a device. Maybe it's making an API call to, uh, I don't know, make a system backup, or maybe you're sending an alert to uh, an email distribution list or a WebEx Teams chat room or something like that. Okay, another thing you can do with pyATS is run test cases, and this is what's most similar to what I mentioned at the very beginning, test-driven development and unit testing. So in test cases, you will build and run tests that are defined in a different YAML file. This is not the same file as your testbed file, and that file basically defines the order in which certain tasks in your tests are run. And those tests are run in stages. So you typically have a common setup in which you're preparing to run your tests, and then you run your tests, which can be a set of triggers and verifications. So typically a verification would be like let's say a show command, show IP BGP neighbors. You look at the output, and then a trigger would be some action or configuration or something that would change the state of the device. So for example, if you went in and you did a shutdown on interface gig 11 and there was a neighbor, a BGP neighbor on that interface, then that is going to trigger a change, right, in your configuration and the operational state of your device. And then when you do show IP BGP neighbors again, you'll this time, you're doing a verification a second time, you're seeing a difference between it and the first time, and so you've got an issue. And then common cleanup would be running those comparisons actually, and stopping any traffic generation or other functions that you define in your test cases. Um, this is like unit testing done in code by developers, but in this case, you're actually using test cases to test the functionality of your network. You know, there are pyATS has mechanisms for running pings across networks, so testing end-to-end connectivity. It's got functionality for running trace routes so that you can actually validate that certain traffic is following a certain next hop path. Um, you know, and then, use your imagination, right? If you want, let's say you're trying to run jumbo frames on your network, right? In order to configure jumbo frames properly, you have to have the MTU bumped up to, let's say, 9,000 end to end across your network. So that means when a certain source is trying to talk to a certain destination using jumbo frames, every single network interface in the path from the source to the destination must be configured with MTU 9000. Well, trying to figure out whether or not that's the case could be somewhat laborious if you're doing it manually, right? Maybe you assign a junior network engineer and you say, here's all the devices and all the interfaces per device that are involved in this end-to-end path. Now go check and manually, show run and make sure that each interface has MTU 9000 under it. Or you could potentially use pyATS for this. You could say learn interface, right? And then you can parse all of the data from every interface and make sure that the relevant interfaces have MTU 9000 within the structured data that is returned. Okay, so you can, and obviously if all of the interfaces have it, then maybe your test case passes. In other words, jumbo frames will succeed in working on your network. But if one of those, even one interface is not configured properly, then your test case would fail. And in this case, jumbo frames would not work. Okay, just an example there. Another thing that you can do with pyATS is you can run device APIs to get information with structured data output. So, in the case of parse, you're actually passing a specific show command. In the case of learn, you're really just passing a specific feature or protocol that you're interested in. In this case, these are APIs that can do very similar things. So you could execute a parse command that says show IP route to look at the routes in the route table. You can also use device API. So in this case, I gave the example of device.api.getRoutes. Well, what does that do? It does a show IP route, and then there are routes in the routing table. So the output of this API would be a list of available routes in the route table. And the reason you might want to do something like that is you want to know if you have a route to a certain destination, because maybe that route houses a network that is hosting web servers for a specific critical business application. And if that route isn't in the route table, you're not going to be able to access said critical business application. Okay, so just trying to give an example. And then finally, actions, right? Because pyATS is written entirely in Python, then really you have, again, use your imagination. What kind of actions can you take based on what you find from these various things? Parsing, learning, comparing test cases and APIs. The results of what you find there may lead you to want to take a certain action. Maybe you want to push configuration. Maybe you want to write data out to a spreadsheet. Maybe you want to send an alert to an email address or a WebEx team chat. Or maybe you want to pass certain information to a ticketing system via an API call. You can use Python request library for something like that. So the world is kind of your oyster, because Python is really a tool belt, and what you can do with it depends on the libraries that you install and import and write code for inside your code base. So you can really take any kind of action depending on the information that you discover with pyATS, and that's what makes pyATS so powerful. Okay, so where, when, and why might you use pyATS? Well, it should be pretty obvious at this point based on what we've already talked about, right? You can use pyATS for network state validation, right? So checking the configuration state, I gave an example of that, and checking the operational state, I gave an example of that. And that in and of itself, monitoring the state of your network is monitoring, right? It's a form of visibility of the status of your network. Is your network working the way that you're expecting it to or not? And then taking any subsequent actions, right? So again, automation, alerting, etc. So where on the devices that are in your test bed. So you may have devices that you don't want to monitor or automate against, then they should not be defined in your test bed. But if you want full network coverage, then every network device in your network needs to be defined in your testbed file. Okay, now finally, how? First of all, it's really important. I know a lot of people out there, including myself, run Windows, and pyATS requires Linux. So you may have Python installed on your Windows machine and be familiar with virtual environments. You may create your virtual environment and then try and run the command to install pyATS on Windows, and this will fail. And I know because I did it. And it took me a few minutes to remember why that was the case. And it's because, very simply, you cannot run pyATS natively on Windows. Even if you have the right version of Python, it's just not compatible with Windows. It requires Linux. So the workaround for that on Windows is WSL, which is Windows subsystem for Linux. So I'm on Windows 11. I run WSL version 2, and I'm running Python 3.8.10. If you go beyond these Python versions, well, let's put it this way. The two most important things for ensuring that pyATS is going to work on your machine is the version of Linux that you're running and the version of Python that you're running. So I run Ubuntu 20.04 and Python 3.8.10, and everything works just fine. So assuming that you're on Windows or you're natively in Linux, if you're on Windows, you've typed in WSL, you've launched your Windows subsystem for Linux, and you're now looking at the Linux command line interface, and you've got the right version of Python, then these are a few commands that you would need to run. The first one would establish a new virtual environment named .venv. The reason I name it .venv is that I don't necessarily, like when I run a tree command to show the directory structure of a particular project folder, I'm not really interested in showing them everything in my virtual environment, which is like, all my Python executables and libraries that I installed with pip and all of that. So this is a hidden directory, but it still functions just fine, right? I just don't want it to show up when I run the tree command. So I've created a .venv virtual environment, and then source.venv/bin activate actually activates that virtual environment. And what that does is it makes sure that when you install software, it is installed in that virtual environment. That makes sure that your Python libraries installed for this particular project don't conflict with the libraries that are installed in your system instance of Python or other projects. Keeps your project requirements isolated. Okay, then you can update pip and setup tools and wheel to the latest version. And then finally, you can do a pip install pyATS square brackets full. And that will install the pyATS framework. It'll install the Genie libraries, which give you your parsing and learning functionality. And I think it installs some documentation and examples for you as well. Okay, so I think that's a pretty good, quick introduction to what is pyATS and Genie. What are they, I should say, and what are some of the features that are available inside this framework? What are some of the use cases? Like, why would you be interested in using this? And some basics on how to get yourself up and running. Now, please, right? This is only like a 30-something minute video. So please watch or take a look at the resources. Um, for me, I did watch the test-driven automation video. I did click through from start to finish the second bullet point there, Cisco pyATS network test and automation solution. But the most important document for actually understanding how to use the pyATS CLI and Python scripts, like if you're trying to get down into a code level and actually use this tool, then that third bullet point is the most important document that I read. And then, of course, hands-on learning, which I personally haven't touched yet because I've just been messing around with the developer documentation. But I imagine hands-on learning has got tons of great examples. So that's something I'll be looking into, and you probably should too. All right. Thanks for watching. I hope this was a useful introduction. Take care.